Welcome to LD Talks. Today we are going to talk about line coding schemes. But before going into more detail, I would like to ask you a question that for say, I'm saying you a binary data stream which consists of any number of ones and zeros. So does it mean I'm exactly sending you the binary data stream, or there is something else is happening somewhere midway into that? So let's check. So this is the talk outline. First we will understand what the basics of the line coding and what it deals with, what is the formal definition of it. Then we will go into the section where we will talk about the several classification of line coding schemes and which line coding schemes we are going to encounter in this course. And then we will talk about the properties of line coding, and we will wrap up the lecture with some applications. So here's the first question, that what is line coding itself? For say, here is a sender who wants to send a binary data to this receiver. I mean, it could be binary data because we all know that the computer deals with the binary data. Maybe for the human perspective, this binary data translated into something else. Okay, so there is an encoder hardware's circuit arrangement is there, which just take the binary data as an input and convert it into some digital signals. And on the receiver side, there is a decoder circuitry which take the digital signal as an input and again generates the digital data, and it's sent to the receiver. So as I already started with a question that if I want to send you a binary data stream, that here it's going to be observed, or it's clear that it's not exactly we are sending the data stream itself. I mean, somewhere in the midway, the data stream converted into digital signals according to the power or voltage or whatever you want to say, and then it's going in the receiver end, and there is some hardware arrangement which translate that digital signal into the digital data which is readable for the receiver. So this line coding is also termed as baseband transmission. In this line coding schemes, we mainly deals with the low frequency signals, and to transmit these low frequency signals we need the serial cables, LAN, which we get to see into our day-to-day basis. So if you want to understand or you just want to know the formal definition of line coding, so there is a multiplexer that is a purely hardware arrangement which takes the binary data stream from the sender side and gives some electric pulses or waveforms, and that is going to be fed into the channel to transmit, and whatever happening inside the multiplexer, that is called the line coding. I mean, we are taking some data and coding it into some waveforms. That's where this line coding terms came from. Okay, so now there is a several type of line coding schemes we will deal with. There's a unipolar, polar, bipolar, multi-level, and multi-transition. In this course, we will mainly confine ourselves with the NRZ and NRZ-L, and there is another variant of NRZ, that is NRZ-I, which stands for this. NRZ-L means NRZ level, and NRZ-I stands for NRZ inverted. And then we talk about RZ and Manchester and differential Manchester. So now this is the important features of the line coding, that there is a transmission bandwidth. So as we saw that it deals with the low frequency signals, we want to keep the bandwidth as small as possible. So more the bandwidth we will allow, the more the noise it will introduce, and the entire transmission get messy. So, and for say any kind of signal of some prefixed bandwidth and error probability, the power whatever it's needed for this transmission, we will try to make it low as much as possible, because if it's more power hungry, then the design or the arrangement is not really economically feasible. So for that thing, we need make sure that the design is power efficient. So now there is another point we will talk about, that transparency. So we will see in a couple of minutes that what is the real example, what is the problem with the transparency itself. For say we are sending some binary data stream which consists a substring. I mean for say I'm sending a 1 1 then 5 zeros then 1, or say 0 0 5 ones then 0. So that means we can see there is a substring which consists a consecutive or a large number of zeros or ones in between somewhere in the data stream. So that data stream may be get misinterpreted and introduce some error in the receiver side. And one of the most important feature we have to ensure when we are designing this line coding scheme, that is the clock synchronization. Because we can see here that for say this is from the sender side, so this is the entire clock period, and here this is represent 1 and this is represent 0, then again this is represent 1. But what if that if on the receiver side that this one beat translated into some more than one ones. I mean, if I take this width of this pulse on the receiver side, if it's counted as more than one times, then obviously if we get the binary data stream out of that, that is erroneous. So for the receiver end and the sender end, we have to ensure that both party are synchronized into the exact time period of the clock pulses. Because if there is some mismatch, the the data stream or whatever sent by the sender, that will be misinterpreted on the receiver side, and we are going to get the entirely different result which is not intended to. So obviously for the design scheme we need some error handling, because any kind of mechanical system, theoretically there is some probability of error. So we need some error handling schemes uh, to detect the errors as good as possible and to rectify it. And there is another important feature that we will see in the line coding scheme, that is called the baseline wandering. Whatever happening in the receiver side, whenever a receiver decoding the signal, whatever we have seen in the second slide, that whenever the decoder gives the output, then whatever the receivers do, that he or she take the entire output and then do some running average over the signal, and this average gives the baseline. So for say, as we saw in the previous slide, that if there is some large amount of zeros and consecutive 1, what will happen, it will push the average uh, beyond the mean, either up of the mean or the below of the mean or something. So for the presence of any large number of zeros and ones, it shifts the baseline. So this is called the baseline wandering. So, and as the baseline drifts with the drift of the baseline, because we will measure the every output coming from the decoder with respect to the baseline. So if the baseline drifts, maybe it's going to be up or the below from the what it should be, then we will exactly translate the sended information incorrectly. So we need some good coding schemes which prevent this baseline wandering. So if we have any large number of zeros or large number of ones as a substring, so we have to ensure that there is some mechanism which will correct all of them. Okay, so for say now there is a signal element with the data element. There's a last feature we're going to talk about. For say we define a ratio, which is a ratio to the number of data elements to the number of signal elements. For say here in the first picture what we are seeing, that that one data element is just considered with the one signal element itself. For say, so if we get some high or low, or in the upcoming slide we will see that we call it space or mark or something. So this is a one data element per one signal element. For in the next, this B figure, we can see this is one data element uh, per two signal elements, because we can see here the clock period of data element is twice of the clock period of the signal elements. So within the data element there is two signal elements are enclosed. That means two signal elements combinedly carrying a one data. In the C, but it's completely different. Here in a single element, one single signal element, we are just coding the two data elements itself. That means one signal element represents 2 bits. And in the last that we have seen that within the 4 data elements are combined into 3 signal elements. So here is the question. So how can we read this entire thing? For say, if there is any problem with this synchronization, so if I'm sending a one data element with two signal elements, and it's translated into something else, if it's translated into one data element per one single element, then obviously we are going to get some erroneous results. So for this thing, that the sender and the receiver both have the idea what is the R of the design. I mean, if the receiver know what is the R of this entire design, then the receiver can detect, I mean, how many data elements are enclosed in how many signal elements. So that will makes the readability easier. So okay, so here we come into the last section of the talk, and this data transmission happening over the LAN and WAN, we know, and this another application is used for the pulse shaping and relocation. In the telephonic transmission, the transfer characteristics below the 30 Hertz, it's highly attenuated. So there we need some line coding schemes to make it efficient and errorless. So thank you. Hope you can understand all the topics I have discussed. If there is any question, you can comment down below. And hope you enjoy. We will explore the other coding schemes as unipolar, polar, and more. So okay, see you in the next lecture. Thank you.